Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about lithium versus sodium battery in 2025. 2025 is about to end, so let's see what happened so far. Well, what exactly is the problem that we are talking about this chemistry level battle, so to say? Well, world's appetite for battery has grown exponentially, meaning right now the amount of battery we are making in one day, a few years ago, that was annual consumption. So we have gone bonkers with in terms of how much battery we want to manufacture. And this whole thing, this whole race of energy storage started with basically lead acid battery, these puppies. And that is in 1860s. That's the first time humanity kind of understood like how can they make a reliable, trustworthy lead acid battery. And by 1880s, it was mass produced, as in if you were super wealthy, you could actually buy this. And if you like, that's very early. Yeah, that's the reason why we had diesel submarines. We had diesel. The moment we had diesel generator figured out, people put dynamo, people put batteries. The end. You got the submarine working. So that's why like submarines, like ancient submarines, still have lead acid battery. So timeline is kind of earlier. Like we have a lot of experience with lead acid battery, but they have reached the upper limit. I don't think we can even do much with it anymore. So that is there. Then World War II happened. A lot of research and development happened afterwards. Nickel metal halides started to come into market. So the research, basically the peak research on battery technology was in 1970. So in that 70s, metal halide was discovered, like a nickel metal halide, these puppies. And I'm pretty sure if you have ever used a rechargeable AA battery or AAA battery, those are that. And by 1990s, it started to hit the market. What about lithium ion? Exactly the same time. By 1970, research was done. By 1990, people started to figure out how to mass produce it. And Sony Corporation became the first corporation that is started, okay, lithium ion is a thing that we are making and we are sending it as a consumer product, commercial launch, not just like a research or satellites or something, no, commercial launch. And it was for handycam. So Sony became the first big daddy for like, yeah, lithium is a thing, it's here. And this time a lot of company, as in like by 2000, a lot of company were experimenting with hybrid. Two main puppies were Honda and Toyota. And you're like, okay, what battery they were using? Nickel metal. And if you ever hear like, Elon Musk did something unthinkable, that was the unthinkable part. Everybody in auto industry knew of nickel metal hydride. They knew of lead lithium ion batteries, but they were not serious about lithium ion battery. It was very finicky. The early lithium ions were very finicky, and not to mention they knew it could go kaboom. So they were like, yeah, putting something that can go kaboom next to a petrol pump, yeah, no. So they were that. And that's why Elon Musk's idea of like, with original Rooster going with 18650 that was made for laptops into a vehicle, that was the big wow moment. Only after that, people are like, maybe we can jump from this to basically lithium ion. So we started to do that, and here's the deal. Right now we are reaching the upper limit of the resources. Let that be very clear. The planet has more than enough lithium, more than enough every single element. It's just that our supply chain is not that good. As in, if you have the money, heck, people will give you money. You're like, hey, I want to establish a battery factory. People are like, shut up, take money. It's just that you do not have resource for that. And I do not mean land or electricity or things of that nature. It's just that you go to a mine. It's like, sir, I want to buy minerals for you. It's like, yeah, sorry, we are pre-booked for 30 years from now. Not even joking. Like literally, multiple national corporations are there, MNCs, and each of them are like, yeah, we are booked for 30 years from here, 20 years from here, 15 years from here. It's like years. So we are looking for some more solutions. So this is the fundamental problem that we are dealing with. Demand has gone up bonkersly and our supply chain is no longer able to keep up. And as of now, people have decided lithium ion is the best, but turns out the supply chain is not strong enough of lithium. And the urgency is very high right now. So let's understand lithium. Now, there are many types of chemistry. Whenever you say lithium battery, it does not mean anything. You have to specify. It's almost like, blood. Like which blood? A blood, A positive, O positive, whatever have you. Like you have to specify. Same goes with lithium. For example, when you say lithium, most of the time you are generally talking about NMC cells, nickel, manganese, cobalt, mobile phone, laptops, things of that nature, or long range vehicles. But there are a lot of other options also. For example, you have lithium, nickel, manganese, cobalt oxide, one puppy. You have lithium, nickel, cobalt, aluminum oxide, another puppy. You have lithium iron phosphate, my personal favorite. You have lithium cobalt oxide, another. Very high capacity. Basically, if you wanted to like just light this LED torch for decades, it's like, I got this. And then you have lithium manganese oxide. rarely used. And then you have lithium titanate oxide. It's like power, it's titanium. It's like you do not worry about it. So a lot of options are there. However, you have to understand, right now, if you are running a lithium factory, lithium may not be, and many times is not, the most expensive component. Meaning, if you are sourcing all the elements, lithium will not be so unstable, so to say, for you, like, or expensive or rare or finicky. Cobalt and nickel many times have much higher prices. Like, and again, the supply chain is the main issue. The material is there, element is there, mines are there, but those mines were not never scaled up for battery demand. So yeah, like lithium scaled up very easily, but then the moment you, especially cobalt is dirty. You have to go for conflict minerals. So price is unstable. It's like, it's messy. Let that be very clear. On paper, it should be clean, but it's like, ooh, it's like you really dive deep into it. Companies don't like it. It's like, it is unstable. Like, especially if you want to have a factory which could have ROI in, like, 15 years, you're like, bro, we need to have stability for 15 years supply chain. That is best luck. So a lot of people figured it out that this is not a stable system. People went to the lab and lithium iron phosphate started to re-emerge. Lithium iron phosphate was built to reduce cost. That's why it has iron and sulfur, basically phosphates. So it is very low, like the cheapest system. And you're like, okay, why wasn't it cheap? There was no mass production. The element cost was low, but mass production was not there. And this basically, NMC cells got the mass production benefit. That's why price was low. Now it's reaching the limit of, oh, the mineral cost is high now. So as of now, world has gone through like a complete what you call role reversal. We started with nickel metal, lithium iron phosphate. Look at very old like Mahindra Evo electric vehicles and all that jazz. They were lithium iron phosphate. Then because of Elon Musk, everybody jumped to lithium, basically expensive lithium, let's just put it that way, cobalt based lithiums. And then they started to catch on fire. And then people realized that's why original engineers were not putting this. So they went back to lithium iron phosphate. Even Tesla went back to lithium iron phosphate. So as of now, lithium iron phosphate has the benefit of everything, as in the supply chain that was there because of laptops and mobile phones and all that for NMC, and the lower elemental cost of the basically iron and phosphates. So right now, the best you can get is lithium iron phosphate in terms of it's cheap, comparatively speaking, it's safe, it does not go boom, it's a very high power. That's one good thing, meaning the chemistry on a fundamental level can support much higher electron mobility. It's like, yo, go. Basically, you're like, I want to drain 1 amp. It's like, I got this. I want to drain 10 amp. It's like, I got this. I want to drain 100 amps. I got this. So it has very high power, like kilowatt, the oomph you can get out of it, it's bonkers. Although, let that be very clear, it does suffer from poor capacity. The safety margin comes from lower voltage. Lower voltage means even though amps could be the same, 200 amp hour, the lower voltage is multiplier. So, tada, you do not get the same kilowatt hour. So, while kilowatt, GG, kilowatt hour, no. Meaning your vehicle will not have stupid range. So, that's the problem. And lithium is very recent. Again, you have to understand, 1990. Like, it's only 3 years older than me. So, fundamentally speaking, that pipeline is not sorted. Lead acid took a long time to sort it out. So at this point in time, battery recycling of lead is like done, go home. Lithium, we have not reached that point. And again, recycling matters, specifically if the elemental cost is high. You start to recycle it simply because it's cheaper. Like, again, that's why we recycle glass, that's why we recycle aluminum. So lithium has not reached that maturity where it's like, okay, it's sorted, this is how we're going to recycle it. So that's the reality of lithium. Let that be very clear. Like, you may think, oh, it's the lithium itself. No, many times it's the unstable supply of cobalt and nickel, or sometimes little amount of tin, or those things are very naughty. Let's just say politically incorrect. And again, business-wise, unstable. So sodium, Na. Now, due to pure supply chain, let that be very clear, it's not that lithium has a fault, it's just that the supply chain of lithium is not that good. And the fact that you have to deal with conflict mineral, people went back to sodium batteries. Wait a minute, went back to sodium batteries? Yes, it has exactly the same timeline. In 1970s, patents were filed and all that. Imagine watching a movie Iron Man 2 and he says, no, like, I have tried every element in every combination. Yeah, we did that in 1970. Everything that is on the periodic table, somebody in 1970 had done it. I can guarantee you that. So that is done. And people lost interest. Why? They calculated it. Flat out, under the known size, under the known periodic table, lithium will always be better. So they're like, then why they are going back to sodium? Well, lithium supply chain is not stable. If you can't manufacture it, what's the point? So 2021, to now. Now 2021 is very few years ago, as in like 3 to 4 years ago. So what happened? Well, 2021, this company CATL, and this is a big manufacturer in Chinese cell chemistry. They they put their money behind it, and they actually started to manufacture at scale. Meaning, if a corporation wants to buy it, they can go yo, my man, I want to make energy storage. They're like, okay, how many cells you want? What size of cells you want? They can do that. Now, how they are doing it is what we call sodium layered oxide using manganese and iron and cobalt. They're like, wait a minute, it has manganese and iron and sorry, cobalt. Isn't that going back to the same thing? Yes and no. While those things are still finicky, they do have the benefit that the price saving from going from lithium to sodium is much enough that it compensates for that. So that is there. Basically, they need transition matter, and almost all, not every single one, but almost all of the chemistry that is available in lithium ion, you can swap the lithium from basically sodium. It can be done with a little bit of wiggle. You can do that. So how lower of power, like how much power loss we are talking about? Because again, people tried it in 1970. You're looking at 5 to 20%. This is their graph. Even this, they are like energy density is a bit lower. And this is their own master plan. But it's like, yeah, it will be lower. Like you're looking at, if I give you 18650 cell, you would be looking at 1300, while lithium iron phosphate can give you 1500. And you're like, does that matter? Yeah, the bigger the pack, the bigger that gap would be. So yeah, 5 to 20% lower capacity. Although it does have power, meaning this puppy is almost like lithium iron phosphate. It can dump current like there is no tomorrow. Like these packs is like, bro, 200 amps, who cares? 400 amps, who cares? 600 amps, who cares? So the current capacities on these packs are bonkers. Like they are so bonkers that car companies are like, hey, what if we have lithium for range and for power I have sodium? Not even joking, they're mixing two chemistry because that's how, it's almost like a capacitor. So this is sodium batteries, Na battery. So what about development? Well, it is way too early. Let that be very clear. It is way too early. And again, it's not even decade old. The very large manufacturer, you cannot just look back into the data sheet, look back into the, environmental studies and data sheets and long-term analysis from insurance companies and all that. There is not enough data. It's just not old enough. So that's the first thing. Another, from engineering point of view, why people hate it. The voltage curve is problematic for inverters, meaning if you're like, hey, it's cheap, I'm gonna buy it. First, it is not really that cheap. Second, if you're like, okay, I'm gonna make a home energy storage, size does not matter. Yeah, the voltage curve does matter, and voltage curve will fry you. As in, if you are trying to make a 48 volt pack, that high voltage, like how high the voltage will go when it's fully loaded, will go 64. Like then why it goes to 64? Because it's almost a linear curve. It drops to 16 volt. So even if you tried like, okay, if I reduce the cell count, you lose the usable capacity. And it is too wide. Like you can understand that 48 volt pack, even in lead acid, does not go fluctuate that much. Going from 16 to 64, it's brutal. And to give you a contrast, how much brutal that is, if you compare that to, let's say, lithium iron phosphate that people are doing, it will go at the 42 volt at fully discharged, and it will go to 58 volt. And again, you have the wiggle room. You can like, hey, people generally do not want to cross 50 volt because the moment you do, it goes into live territory, aka the certification becomes expensive. All the insulation have to be double insulated because at that point in time, there is a very high risk. It can jump through your skin and shock you. So that's why even USB power delivery is limited to 48 volt. You do not want to cross that 48 volt threshold. So you can switch one cell down and you will still have decent enough system. And what does it mean for you and I, or electrical engineer or PCB engineer? Yeah, for let's just say you are making a 10 kilowatt hour battery pack. It is available. I'm talking about, this is realistic. You can buy it right now, even in India. So a 10 kilowatt powerhouse would require 625 amps at 16 volt. Basically, once this is fully reaching its last capacity, you have to draw 625 amps. That is brutal. Compare that to lithium iron phosphate, that only goes to 238. It is multiples gap. Like it's not something like your inverter, even if it can work at low voltage, even if it has the PWM cycle that it can boost that low of a voltage, it just won't have the current carrying capacity. It will just like, yo, my man, no. What does it mean? It simply means your tank capacity goes down. It's basically going back to lead acid battery, where it was like, hey, your lead acid battery, you can calculate, oh, I have 4 unit lead acid battery, as in 4 kilowatt hour. No, you don't. You only have 2 because the circuit will cut off at 10 10 volts. So, and again, it has to do that, otherwise you will damage it. So round trip efficiency on lead acid battery is bad. I'm living it with it, so it's really, really bad. And again, you don't want that. People don't want to go back to that. People want to like, hey, give me the full capacity. I'm paying for the goddamn full capacity. So again, the current becomes a fundamental limitation. Your PCB becomes more expensive. The amount of MOSFET switches or IGBT switches you need would become bonkersly high. Everything becomes brutal at those sort of systems. Now, how much better is it from lithium? Well, not that much. Practically speaking, you can beat almost all sodium ion that is available in the market with lithium iron phosphate. And if you really want to flex, you're like, no, I want to flex this puppy out of this world, go to lithium titanate oxide. The moment you go to lithium titanate oxide, that has cycle life that makes sodium look like, bro, don't try. Like sodium is like, I am 10,000 cycle. Lithium iron phosphate is like, bro, the early versions we made was 20,000 and we have it on satellites. We have been using it. Like, don't worry about it. We good, bro. We good. So if you want to flex, go lithium titanate. It does have lower capacity, but again, in terms of temperature range, it works from -20 to -60 degrees Celsius. It's like, you put it and forget it. You can use it in Alaska to Sahara desert and it will be like, bro, I got this. I got this. Lithium titanate oxide. I got this. Current is like, bro, I can handle lightning. That's how powerful that puppy is. And lithium iron phosphate is like, balance of everything. So it's not that much better. It's like, what are you actually gaining from switching all that jazz? And again, this is the another aspect of it. It also has the same chemistry availability as in like NaV2PO4F3, NaFePO4F, Olevians, NaTiO3O7. And I'm pretty sure that's sodium titanate oxide, but the voltage is like almost half a volt. So it gives you the highest capacity here for some reason. But I'm pretty sure that's the penalty. Like capacity goes high, but like the voltage goes so low that you might need way too many cells. The BMS would be like, bro, I give up. You have like 500 cells for 200 volt. So that's the issue. It's not really like, again, all these chemistry have been developed. Again, we have tried this from 1970s. It's just that that's why we gave up on it. It's like, it's not that good. And again, lithium iron phosphate is now yielding the benefit of full development, where it's like we got the mass production of 18650s for laptops and all that jazz, and all other chemistries for mobile phone and all that, taking all that mass production benefit and lower elemental cost. And lithium iron phosphate is not that much expensive in contrast to sodium. So right now, even if you pick up a phone and call to the big puppies, it's like, yeah, it's not that much cheaper. And again, even if it is cheaper, you lose all of that benefit in other ways. So let's talk about those things. So right now we are in what we classify as gambling phase. We do not know how the chips will fall. So sodium is cheaper than lithium. That is like, duh. And again, there is more than enough lithium in the earth crust. I'm not talking core, just the crust that we sorted. Heck, most countries have lithium. They have never developed the goddamn mining industry around it. And again, there was no need for it. It's like people are really not understanding how recent lithium is. Like iron, steel, aluminum, those sort of things, silicon, those things we have been mining for a long time, where it's like, we good, we got this, we done. Aluminum used to be very expensive. So fundamentally, the price gap, it can dip, and it can dip so much. Like if lithium prices goes down by even half, which again still would be more expensive than sodium, nobody will even touch sodium at that point in time. And how can that physically happen? Well, new mines. That's the biggest issue right now. India has ginormous resource of lithium. We just never mined it. And we knew this during British era. There was no use for it. Germany has lithium deposits. There was no use for it. There are like many geological studies are like, yeah, we have lithium here, we have lithium here, we have lithium. We just never developed it. Okay, that's why I said and if you try to develop a mine, it takes few years just to get the permit for it. And God help you if you are in European Union. So reality is, new mines can easily tank the price. Another is, once the lithium price goes high enough, recycling will become more desirable. And all those batteries are disposable. At some point, they will become use and throw. So you use it 10 years, 15 years, 30 years, you have to throw it. At that point in time, once you start to recycle it, even with a decent enough recovery rate, it will tank the price. So there is a realistic pathway where lithium prices can tank so much that sodium just becomes pointless. And other things do matter. For example, shipping cost. For example, it's like, let's just say America is like, okay, I want 100 gigawatt hour batteries capacity, so to say. How much sodium ion batteries you have to ship versus how much lithium iron phosphate you have to search. Like it would be a difference of few ships. Like you have to send a few ships less if you want to do it with basically so to say, sodium. And another aspect, conductor. Because of those amp requirement, the conductor cost would be high. And again, conductor is copper. Copper is expensive. So the amount of money you will save, you will lose in conductor. Another aspect, high amps, the circuit switching elements and all that, yeah, those will cost money. Plus BMS circuit, you can have a microcontroller based, like programmer based system that can do BMS, and people are doing that. But again, you're not going to bring that to a car. Car supposed to be driven by what we call ASICs, as in application specific integrated circuit. Those haven't been developed and verified enough. So those are not cheap. So once you account for all these things, that's why I said the price can dip. And again, there are more than enough people who are like, hey, we should develop some more lithium mines. And again, there are people who are trying to bring lithium mining in America. Yes, America has more than enough mines for lithium. It's like, then why they have it? They haven't developed it. So again, this is the part you have to understand. Like, geography is like, bro, we got this. You have lithium. It's not neodymium. Lithium is like, we there, we good, we good. China is, I think, third in terms of supply output. So we good. Lithium is there. It's just that we haven't developed the mining town, so to say, of this. And we have gone through this whole supply chain, which is aluminum. As in, back in the day, aluminum was discovered. Once we figured out how to make aluminum, it was so expensive that gold was for poor people. And like, what the hell? Yep. As in, like, if you are like in your royal palaces, if the royalties did not like you, you're too poor for them, they're like, eat in gold plates, man. If you're like, oh, delegated guest, aluminum plate. That happened. Like, that actually happened. This is the time aluminum was like, whoa. It's like, whoa. Then what happened? Well, we discovered electricity and electrolysis. We electrolysis the hell out of aluminum, and then it's like, ta-da, bye. So that happens. So lithium is almost in the same phase. And again, this took decades to happen. So all this idea, oh, lithium is expensive, lithium is, it's not developed, man. Like, mines are like, there are places where like, bro, you can take me. Like, nobody lives around me. Oh, although to be fair, you do need railway network, you do need a small town, you do need like small hospital and all that jazz. So it does take time to establish a system, but it is doable. And again, what about environmental catastrophe? Even now we have better systems. We have better systems where you can deal with acid mine drainage and all that issue that's supposed to happen after dealing with mining. We can even handle that. So there is a real gamble pointer here. You can go to sodium. Again, I lost interest the moment I looked into the voltage curve. It's like, yeah, it's literally like a supercapacitor. Why don't we make a UPS from supercapacitors? It will last forever. And again, I think I might have to replace my another UPS battery, because again, batteries are consumable in UPSs. But if it was capacitor based, you never have to worry about it. But then why don't we? The voltage, it has to try to pull energy from almost 0 volt. So that's the main issue. The voltage curve is brutal. It's same problem as system. And another thing, everything else has to change. So are you actually saving money? It's like, it looks fine, but by the time you're done with everything, it's like, is it? So that's why I will say it's a gamble. My money is on lithium iron phosphate, not on sodium, simply because, again, something interesting could happen. Somebody could figure out a new spice formula that makes it very flat. Then I could be interested. But right now we are not there yet. So this was my presentation on lithium versus sodium battle in 2025. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me excitement. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.